Now let's talk about vectors in R. Vectors are one of the most fundamental data structures that we will work with. They store elements of the same type such as numbers, characters, or logical values. To create a vector, we use the C function. So C, comma 1, 2, 3 is a vector that stores these numbers. To We can also generate a sequence very easily. Suppose we want to generate a sequence of 1, 2, 3 up to 10. Then we use this function sec, like seq, parenthesis 1 comma 10. This will generate a sequence of the first 10 natural numbers. Uh, to my knowledge, vectors can have more than one type of data, like numeric and non-numeric, but it's usually a very, very bad practice to have numeric and non-numeric data in one vector. You should always keep them apart. Using these vectors, you can do element-wise operations. So, for example, you can add them up. So if you have two vectors, one has 1, 2, and 3, and the second vector has 4, 5, and 6, and then you add them up, it will do an element-wise operation, which means it will add the first element of vector 1 with the first element of vector 2, second element of vector 1 with second element of vector 2, third element of vector 1 with third element of vector 2. So this is what we mean by element operation. You can also do operations like subsetting, which is often useful in different coding contexts. So what we mean by subsetting is that you have a vector of 10 entries and you want to carve out the first three elements of that vector. So you so let's take a step back. Let's start with something more simple. So you want to extract the first element of that vector. So you type v square brackets 1. The 1 over here re it refers to the position of the element in that vector. So 1 stands for the first position. 2 stands for the second position. So if I had typed in v per square bracket 2, then I would have extracted the second element of that vector. If you're familiar with Python, then you would know that there it's a bit different, but we are not going to go into that. So that's a redundant digression. Forget it. You instead of doing an element by element subsetting, you can also pick chunks of it using a command like this over here. This means that I have a vector of, say, first 10 natural numbers, and I want to extract the first three. So what I'm going to do is I'm going to type v square brackets 1 colon 3. So out of this vector of 10 elements, I will draw the first three elements. And you can also run functions through vectors like sum and mean. So if you type sum v, then it will add up all the elements of that vector and give you the total. If you want to calculate the average of all the entries in the vector, you use the mean function. Unlike vectors, which usually is one type of data, lists can store different types of data. So we use list function to do that, and we can access elements of that list in a very similar way. But note the double square brackets over here, or using a list $ name function. Matrices are two-dimensional structures where all elements must be of the same type. We create a matrix using the matrix function. For example, uh, I have this command, matrix assigned 1 colon 9 n row 3 n col 3. That's there in the R script that I've shared. So that what it will do is that it will create a 3 cross 3 matrix filled with numbers 1 to 9, where we can access the elements using the row, comma, column. So if you want to access the element in the first row and second column, then we write the name of the matrix, square bracket, 1, comma 2. Matrix operations are very, very powerful. You can perform element-wise operations such as additions and multiplications. You can also perform matrix algebra like transformation functions as well. Arrays extend the concept of matrices to more than 2 dimensions. We can create an array using the array function. For example, you have array 1 colon 12 with dimensions C3 to 2, which means that we will create a 3 cross 2 cross 2 array with 12 elements spread across 3 cross 2 dimensions. So it's not like we are just now playing around with the dimensions. Arrays are useful for handling multidimensional data and usually used in relatively more advanced computational stuff. Finally, let's talk about the factor variables. Now, factor variables are different from numerical variables because they represent categories. So if you have a data set where your or data on gender, you have men, women, and other genders. So we use categorical variables to club them into the same group. Okay, so all people of the same gender are in one group. This can be done using the factor command. So once we use this factor command, we get defined levels. So each group gets assigned a value, which doesn't mean much except the fact that all individuals with the same factor level belong to the same group. They are often used as statistical modeling. We often use group-wise plots using categorical data. It's obviously used a lot in ANOVA and regression, and it's often an efficient way of dealing with data that is of this nature. So this is as far as the basics of R is concerned. I hope that was useful. This is just the tip of the iceberg. This is just to get you started. If you have already taken data analytics courses with Dr. Littlejohn, or if you've been in my metrics class, you're already so if you have already been in my metrics class, sorry if the video recording got interrupted. You have already done a bit of R, so this is just to get you up to speed. There are tons and tons of videos on YouTube that you can take a look at to get yourself familiarized. And this is just, I'm just trying to guide you in the right direction. So that's it from this topic. I'll be back with a different topic very soon. Thanks.